Okay, guys, so let's start now. We'll be doing proving today. I'm sure most of you have experienced proving questions in your midterm exam, right? Maybe not all the questions, but you should know how to do the proving questions as it contains a lot of marks, right? Okay, just a minute.
Okay, hello everyone. So we'll start with from chapter 1 first, which is functions for the proving question. Uh, okay, so Pritika, can you show the question and answer to solution together? Okay. Okay, so the question is saying that given that fx equals x squared, x is more than or equal to 0 and gx equals to negative square root x, where x is more than or equals to 0. Find f gx and g fx, hence determine whether gx is the inverse function of fx or not. State your reason. Okay, so this is, you have to prove whether if it's inverse function or not. Okay, so at first you have to find f gx. Pritika, scroll down. Okay, so f gx equals to f big bracket gx close big bracket, and then from the question we know that gx equals to negative square root x, and then we also know so this and then we also know fx, so we just insert it, and then we'll get fgx equals to x. And then they also asked to find us gfx. So g in big bracket fx close big bracket, and then we know both the question has given us both gx and fx, so we can put it inside, then we'll get negative square root x square. Gfx equals to negative x. Okay, and then since gfx is not equals to x, because fgx is x, that means gx is not inverse function of fx. Okay, okay, next question, next proving question. We are not doing revision class, like we are doing questions on provings. Okay, Pritika, next question. take out. Hello. One moment now.
Okay, so the next proving is uh, from chapter 2, quadratic function. Okay, so one of the famous formula which we have seen is x equals to negative b plus minus square root b square minus 4ac divided by 2a. So the quadratic equation will be in general form, which is ax square plus bx plus c equals to 0. All right, so how to do the proving? Um, you need to know a method called completing the square. All right, so starting with the general form, ax square plus bx plus c equals to 0, and then you factorize it, which will turn into a big bracket x square plus b over a x plus c over a close bracket equals to 0. And then if you remove the bracket, it will turn into x squared plus b over ax plus ca is equivalent to 0. And at this point, you must do the completing the square, right? So x plus b over 2a close bracket square minus b over 2a square plus c over a equivalent to 0. I'm sure you guys know the completing the square method, right? So this part is very important because you'll be getting the marks. And then it's like factorization, like bring the x this side, and it will turn into x plus b over 2a close bracket square equivalent to b square over 4a square minus c over a. And then if you summarize it, it will turn into x plus b over 2a square equivalent to b square over 4a square minus 4ac over 4a square. Okay, and then from there, the square, the previous method, you saw the square, right? So if you bring to the other side, it will turn into square root. So it will turn into x plus b over 2a equivalent to positive plus minus square root b square minus 4ac. Can you see this part? B square minus 4ac, it's just like take that part and just put there. Since there's two 4a square, you just put one time. This is also equivalent to the above method. And then you summarize that part, and it will turn into x equals then to negative b over 2a plus minus square root b square minus 4ac divided by 2a. Last but not least, it will turn into negative b uh, plus minus square root b square minus 4ac divided by 2a. 2a, they only wrote one time because both sides before the positive negative also got 2a, after also got 2a, so you just write one time should be fine. And that's the proving for quadratic. So can you all understand? You all okay? Today we'll be doing proving. Alright? Proving is very, very important. Okay, let's go to the next part. Given the quadratic equation ax squared plus bx plus c equals to 0, which is a quadratic, uh, quadratic formula where a, b, and c are constant and a is not equal to 0, has roots alpha and beta. Show that alpha plus beta is equivalent to negative b over a and alpha beta. Alpha beta means times, so it's alpha beta equivalent to c over a. It's a small formula only, but it's important. So general form ax squared plus bx plus c equivalent to 0. Just like the computing the square method, just now we studied, right? Just the same method only. Alright, a bracket x squared plus b over ax plus c over a is equivalent to 0. Factorize it. Okay, and then x squared plus b over ax plus c over a is equivalent to 0. We put here 1, so later you can show. Okay, and then you see x minus alpha bracket, then x minus beta, normal factorization only. X times x is x squared, negative a times negative b is negative a times x is negative ax, negative a times negative b is negative bx, and then plus ab equivalent to 0, and then x squared minus bracket alpha plus beta is close bracket x plus alpha beta is equivalent to 0. So if you compare both equation, x squared plus b over ax plus c over a equivalent to 0, and you compare second equation, x squared minus alpha plus beta x plus alpha beta equivalent to 0, you'll be getting alpha plus beta. Alpha plus beta is negative b over a, and alpha beta will be c over a. Can you see here? Right? I hope I'm not too fast because there's a lot of proving. This is one of the simplest ones. Yeah. Okay. I hope it's alright. Can't see the comments. Just put a thumbs up if it's okay. We'll be moving into logarithm. There are a few formulas for it, which we're going to continue.
Okay, so next chapter we'll go into logarithm. We don't have any formula for chapter 3, so there's no proving for chapter 3. For chapter 4, there's quite number of formulas, so we'll have to prove for each of the formulas. Okay, this chapter quite popular in exam, so they might ask, so must take note for chapter 4. So the first formula is so the first question is, given that m equals to a to the power of x and n equals to a to the power of y, show that log a mn equals to log a m plus log a n. Okay, so how we'll show is, at first we will, since the question has already given m equals to a to power x, n equals to a to power y, then we can log a m will be equals to x, because Kritika, can you go down, scroll down? Okay, log a m equals to x, because if you add in log to both sides, then the power x will come in front, then log a will get cancelled. Okay, so and then mn equals to a to the power of x times a to the power of y, and since they're same base, you can plus the powers, so mn equals to a to the power of x plus y. So you can insert log a to both sides, and then log a mn equals to x plus y. Why is it x plus y? Because when you insert log a to the right hand side, the power will come in front, and then log a will get cancelled. So since we know x and y from above, then you can just substitute, then you'll get log a mn equals to log a m plus log a n. So that's how you prove this formula. Okay, understand? If you don't understand, we can go to the next formula. Okay, so this is the second formula. Given that m equals to a power x and n equals to a power y, show that log a m over n equals to log a m minus log a n. So this is similar to that, but this is for division. Okay, so the same thing, the question has given m equals to a power x, n equals to a power y. So we insert log to the both sides, and then we will get log am equals to x, log an equals to y. This concept is the same thing from the formula before. Okay, so Kritika, scroll down. Okay, and then so m over n equals to ax, a to the power of x over a to the power of y. This is simple substitution from the question. Okay, and then m over n, since the base are same, you can minus the power x minus y, so m over n equals to a power x minus y. Then can insert log to both sides, and then we'll get log a m over n equals to x minus y. X minus y is because when you insert log a to the right hand side, the power will come in front, then log a will get cancelled since they're same base. And then log a, since we know x and y's value, then we can just substitute log a m over n equals to log a m minus log a n. So this is how we prove this formula. Okay, any question? Understand? Can go next formula. Okay, so this is the last formula to prove in chapter 4. Okay, so if a, b and c are positive numbers, a is not equals to 1 and c is not equals to 1, show the method to derive log a b equals to log c b over log c a. So this is the formula when you change one base to another. That's the formula. Okay, so at first we assume log AB equals to x. So B will be equals to A power x. Because we move the log to the other side, which is anti-log, we move to the Pritika, scroll down. Okay. So we move the log to the other side, which is known as anti-log, and then when we move the log to the other side, the base will become the index, and then the number after the equals will become the power. So B equals to A power x. And then ax equals to A power x equals to B. It's just the same thing from above, but they change the position. So if we insert log C to both sides, so log C A power x equals to log C B, then we can bring the power in front, so it will become x log C A equals to log C B. And then we can move the log C A to the other side, so x equals to log C B over log C A, and then we know the value of x, which is log A B, so we can substitute inside. Then we'll get the formula log A B equals to log C B over log C A. This is how we derive or prove for this formula. Okay. Any question? Understand? Okay, so now let's go for chapter 5's proving questions. Chapter 5 is also one of the popular questions, popular topic that can come out for proving other than chapter 4 and 2. Wait, let me see what's the question. What about proving log z? Sorry, I don't get your question. Log z? You mean log base z? Oh, for that that kind of log equation, there's no proving question, because it's just a law. You just bring the power in front. There's no proving for that. Okay. I hope that answered your question. Okay, let's go to chapter 5 now. Okay, chapter 5 is so popular, other than chapter 4 and 2. So chapter 5 we have quite a number of proving questions, so please take note. So the first one is for Sn, proving for Sn formula for arithmetic progression. Okay, so the question says if A is the first term and D is the common difference of an arithmetic progression, show that the sum of the first n terms of the progression is Sn equals to n over 2 in big bracket 2a plus small bracket n minus 1 close small bracket d close big bracket. So this is basically the formula for Sn for arithmetic progression. So they are asking us, technically they're asking us how do we get this formula. Okay, just scroll down a bit. Okay, so Sn, we know it's a sum of the total terms in a sequence. So we can also say Sn equals to t term 1 plus term 2 plus term 3 plus so on until the term n, which is the last term. Okay, so we know term 1 is a since it's the first term, and then term 2 will be a plus the common difference, which is d, the question has given, and then term 3 will be a plus 2d because we are plussing two times of the common difference. Okay, and then for the last term, which is tn, will be equals to a plus in bracket n minus 1 close bracket d. Okay, so that's the sequence. You have to just sub into the sequence, and then since you know Sn equals to a plus d plus a plus 2d and so on until a plus n minus 1 d. Okay, so to get that formula you have to plus another Sn. So Sn plus Sn will be 2Sn, Sn plus Sn. We'll have another Sn, which is a plus n minus 1 d plus a plus n minus 2 d plus a plus n minus 3 d, and then plus a. Okay, and then we are writing this because this is in this the first Sn, which is a plus d plus a plus 2d plus a plus n minus 1 d, is if the sequence of term is in ascending order. Okay, but the second Sn, which is Sn equals to a plus n minus 1 d, a plus n minus 2 d and so on, is if the sequence is descending order. So it's, you have to write both of that and then plus both of the Sn. So you'll get 2Sn and then a plus n minus 1 d, you'll get 2a plus n minus 1 d, and then so on. You plus both the terms together, and then you'll get 2Sn equals to 2a plus n minus 1 d plus 2a plus n minus 1 d plus 2a plus n minus 1 d plus so on, and until the n is 2a plus n minus 1 d. So down there you can see 2Sn equals to n equals to 2a plus n minus 1 d. So we are just the n here represents the number of, because since 2a plus n minus 1 d is repeating plus 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 plus, so n represents the number of 2a plus n minus 1 d. So and then the 2Sn, you move the 2 to the other side, you'll get n over 2 in big bracket 2a plus n minus 1 d close bracket. Okay, so that's how you get this formula. It's quite complicated, but if you understand it, then it's easy to prove that formula. Okay, so let's go to the next formula. Okay, so this formula is not very popular, but it's quite rare, but I'll still go through it. Okay. In an arithmetic progression with n of kita scroll up the question. Okay. In an arithmetic progression with n number of terms, it is given that a is the first term, L is the last term, and D is a common difference. If Sn is the sum of first terms of the progression, show that Sn equals to n over 2 big bracket a plus L close bracket. Okay. So for this we do almost the same thing. We list up the Sn, which is term 1 plus term 2 plus term 3 and so on. And then we do the same thing. We list the Sn in ascending order, which is a plus d plus a plus 2d plus n plus until a plus n minus 1d. Then we also write the Sn in descending order, which is a plus n minus 1d, a plus n minus 2d, a plus n minus 3d until a. And then we plus both the Sn, we will get the same thing from the before question, which is 2Sn equals to 2a plus n minus 1d, and plus the same thing again and again and again. So we know if we are plusing the same thing again and again, so you can write 2Sn equals to n in big bracket 2a plus n minus 1d close big bracket. And then we move the 2 to the other side, but this time we separate the 2a, we write it a plus n minus 1d close big bracket. Okay, so since we know the Tn formula is a plus n minus 1d, we can substitute Tn into that part where it's written a plus n minus 1d. So you'll get Sn equals to n over 2 big bracket a plus Tn close bracket. And then we know Tn is the last term, and the question gave last term is L. So we can just write L, substitute L there, then Sn equals to n over 2 a plus L. Okay, I think I'll go down. Okay, you can see here. You understand? Okay, next equation. Okay, this is the formula for Sn for geometric progression. Okay, if a is the first term and r is the common ratio of a geometric progression, show that the sum of the first n terms of the progression is Sn equals to a bracket r and r to the power of n minus 1 close bracket over r minus 1. This is the Sn formula, if you all still remember. So how are we going to prove? First, the same thing we list out, since you know Sn equals to term 1 plus term 2 plus term 3 plus so on until the last term, which is term n. But in this Sn, we don't write a plus d, a plus 2d, because this is geometric. So we'll write a plus ar power 2 plus until ar n minus 1. We write ar is because for geometric we'll times the common ratio to the term before it, so it's ar, and then ar power 2 and so on. Okay, So that's the first equation we have to label. And then the second equation will be your times r to the Sn. So you'll get r Sn equals to ar plus ar square plus ar cube plus so on until a r to the power of n. Okay, and then we have, that's equation 2. We have two equations, so we will do elimination method. Kritika, go down. We'll do elimination method where we'll minus equation 2 with equation 1. So we'll get r Sn minus Sn, and then ar plus ar square plus ar cube plus so on until ar power n minus a plus ar cube plus so on until ar n minus 1. Make sure to put the bracket because it's minus. Okay, you will have to expand later. Okay, since at the left hand side Sn is the same, we have, so we can factorize Sn out. It will be Sn in bracket r minus 1 close bracket equals to ar minus n. So how we will get ar to the power of minus to the power of n minus a is you all have to expand the negative inside and then minus each one of it, then you all will get ar to the power of n minus a. So since both you can factorize out a, so you'll get Sn r minus 1 equals to a bracket r power n minus 1 close bracket. Then you all can move the r minus 1 to the other side, so you all will get Sn equals to a rn minus 1 close bracket over r minus 1. So that's how you get this formula. Okay. Okay, so next formula. Okay, this is the Sn formula for geometric also, but this is 1 minus r. The before one was r minus 1. Okay, so we do the same thing. T1 plus Sn equals to T1 plus T2 plus T3 and until Tn, and then we list out the same thing. Sn equals to a plus ar square and then until ar n minus 1. Then we do the same thing, we times r, and then we'll get rsn equals to ar plus ar square plus ar cube so on until arn. But the only difference, we have the difference here from the before question is, the before question we did equation 2 minus equation 1, but for this proving we will do equation 1 minus equation 2. So Kritika, go down. Okay, so Sn minus rsn equals to a plus ar cube a plus ar square plus so on until arn minus 1 minus ar plus ar square plus ar cube plus and so on until arn. So since we know Sn is the same, we can factorize Sn out. So we'll get Sn 1 minus r equals to a minus ar to the power of n. And then we know a is the same here, we can factorize a out. Now we'll get Sn 1 minus r equals to a in bracket 1 minus r power n close bracket. And we can bring the 1 minus r to the other side, then we'll get the Sn equals to a in bracket 1 minus r to the power of n over 1 minus r. We will get the formula. Okay, understand? Okay, we can go to the last formula. Kritika? Okay, this is the last formula for chapter 5, which they might ask to prove, which is S infinity formula for geometric progression. So the question says, if A is the first term and R is the common ratio of a geometric progression, show that the sum to infinity of the progression is S infinity equals A over 1 minus R. Okay, so we know the formula for Sn is equals to A in bracket 1 minus R power n close bracket over 1 minus R. Okay, and then when R is infinity, the ratio is infinity, we'll know that R to the power of n will be 0. So 1 minus R to the power of n, which is 1 minus 0, will be 1. Therefore, if we substitute 1 into the equation, it will be A bracket 1 over 1 minus R. So S infinity will be equals to A over 1 minus R. So that's how you get the formula. Just scroll down a bit. Okay, so that's all for chapter 5. Now chapter 7.
But before entering proving chapter 7, I was wondering, can we do chapter 7, like start the topic? Because chapter 6, a lot of graph you need to draw. And I'm not sure chapter 6 how to teach online because it's going to be very hard. So what do you guys think? Can you put in the comments? Guys, so what do you think? Because if you see chapter 6 here,
They say
Only
chapter
about
7.
chapter 7. Okay. Okay, we'll start chapter 7. I'll present my task. May I know school which chapter are you guys in? School which chapter are you guys in? Oh, chapter 4. Okay, so we are in advanced lab. But good also to learn advanced, I feel. Just a minute. This is chapter 7. Coordinate geometry. It's actually one of the easiest chapters. So there are a few formulas which you have to know in this chapter. Very simple formulas. By mastering these formulas, you can also uh, score in your proving also because it's almost alike. Okay, so shall I show the proving first? You guys wanna go into the chapter? I think I'll go into the formula first. Okay, formula and proving. So this is a formula for chapter 7. Okay. So in the following diagram, PXY divides the line segment AB in the ratio M ratio N. Show that the formula X, Y is equivalent to NX1 plus MX2 over M plus N, NY plus MY2 over M plus N. So it's basically the proving, right? When you see the midpoint P, and there's also 2 points A and B. Middle has M and N, right? So I'm sure you guys know the midpoints of P, right? it will be helpful for this chapter. So x minus x1 divided by x2 minus x. So where is x minus x1? Can you see x? X is in the middle, midpoint, P, right? x1 is here at A. So x minus x1 divided by x2 is in B minus x again, which is the midpoint. Okay, equivalent to mn. Always take m and then only n. That's the order. Okay, and then nx minus nx1. Like just now, x minus x1, right? Just like that. Nx minus nx1. The formula. This is proving. Okay, equivalent to mx2 minus mx. So you bring the like terms together, which will turn into nx plus mx equivalent to mx square. It's not, sorry, mx2 plus nx1. And then you see the common thing here, which is the x, right? So you factorize it. So it will become x bracket m plus n close bracket. Okay, equivalent to nx1 plus mx2. So if you like expand and all, it will turn into x equivalent to nx1 plus mx2 divided m plus n. You bring this is times, right? X times m and then x times n. So you bring it to the other side. Times, you bring it to the other side, becomes x. Divided lah. This is for part x only. We have something called part y. It's exactly the same. Alphabet only different. Again, y minus y1. Y is in the midpoint P. y1 is in A. Okay. y2 is in B minus y again, which is in midpoint P, equivalent to m over n. Always m over n. They give you here number example. Here they give you 3, 2. 3 means m, 2 means n. So you have to put 3 divided by 2. Put opposite. So ny minus ny1 equivalent to my2 minus my. So ny plus my, again like terms we bring it to the left side, non-like terms we bring it to the right side. Ny plus my equivalent to my2 plus my1, and then you factorize it. The common thing in here, which is the y, right? So you put y m plus n. ny1 plus ny2, y remain here, ny1 plus my2, this one is times the relationship, y bracket m plus n, right? If you bring it this side, it will become divide. Okay, so if you gabung both of it, this one x and y, it becomes bracket x comma y, close bracket is equivalent to nx1 plus mx2 divided by m plus n. Same thing, copy and comma ny1 plus my2 divided m plus n, close bracket. That's the first thing you have to know in this chapter lah. I hope you guys are not confused, because this one is inside the textbook as well. The exact same thing. Exact same thing. You see in the questions, when you see like numbers, like numbers like this, then it would be easier lah to do. But if you see alphabets, it would be a little bit hard. Okay, so since I've explained the proving for this, let's go into example 2. So in example 2, the coordinates of points A and B are -5, -2, and 5, 8. If point P divides line segment AB in the ratio of 3:2, find the coordinates of point P. So P, we don't know what's the coordinate, but you know A and B. And also they give you 3 and 2, which is the M and N lah, the ratio. Okay, so let's solve A first. So P, they want you to find the coordinate, right? So it would be X, Y. And in the exam, if they don't give you, the diagram they won't give you, so you draw it by yourself. Just put one line, label and all, so it will be easier. Divides AB into ratio 3:2. They divided 3, 2. Can you see? Okay, so see here, they put X coordinate of P, right? The exact same formula. You just use this formula. Can't recall if this formula is given in the exam. Not very sure. I think they provide it, but you guys still need to know lah. Okay, X coordinate for P, 2 times -5. 2 times -5. Where is the 2 coming from? 2 is actually the M and the ratio. 2 times -5. This side, the point A. Okay, plus 3 times 5. 2 times -5, 3 times 5. It's like a M shape. You draw on top of it. You see again. 2 times -5 plus 3 times 5. It's like a M lah. Draw. Divided by 3 plus 2. Bottom part is just plus the ratio. Okay, but you have to write 3 plus 2. I know it's 5, but just write last. 1 mark maybe. So 2 times 25 into 10. 3 times 5 is 15. 3 plus 2 is 5. Solve it, use your calculator, get 1. So now you have the coordinate of X. Now you want to find Y, right? Use the exact same method. So 2 times -2. 2 is from here, ratio, times -2. -2 is A, from point A, okay? Plus 3 times 8. Again, another M shape when you draw. Okay, 3 plus 2 is the ratio, 5, right? So 2 times -2, 4. Sorry, 2 times -2 is -4, plus 3 times 8 is 24. Divided by 5, 20 over 5, which is 4. So coordinate X is 1, coordinate Y is 4. So it will be coordinates of point P, midpoint P will be 1 and 4. Can you guys understand? Can I understand? Cannot. Can I understand? Darman, Ahmad, Joel, Hannah, J. Continuing with B. Points A, -7, 3, P, 5, -3, B and M are on the straight line. Okay. Given P divides line segment AB in the ratio of 3:1, and the M is the midpoint of AB, so M must be in the middle. Okay. Find the coordinates of B and M. B is not given. Okay. D is X, Y, and P is 5, -3. Divides AB. Okay. In the ratio 3:1, ratio must be in like M and N. Just now the bully showed you that, right? So remember that. So X coordinate of P is 5. X label that small, you can write that X, Y. So X is X is 5 for P, and then Y is 3. but focus on x. P equals to 5. So 1 times -7. Again, that M shape thing. 1 times -7 plus 3 times x. Because B is x. Okay? Equivalent to, divided by 3 plus 1. 3 plus 1. Ratio. Ratio always plus. But you have to write that 3 plus 1. Equivalent to 5. Because x is 5. Can you see that? P 5 is x. Okay? 3x minus 7. How do you get that? You solve it. 1 times this 1 is 7, 3x. Simple. 3 plus 1 is 4. 4 you bring this side. 4 times 5, 20. Then 3x equivalent to 20 plus 7. Bring the 7 this side. Will turn into 27. X divided by 27 divided by 3, which is 9. But the coordinate, x coordinate is 9. Let's find y coordinate now. P equivalent to -3 for y. Y is -3. So 1 times 3 plus 3y. 3y is 3 times y lah. Divided by 3 plus 1 is equivalent to -3. -3 is the y coordinate. So 3 plus 3y, simple algebra. 3 plus 1, 4. 4 times -3, -12. 3y divided by -15. Bring the 3 this side. Y, -15 divided by 3 is 5. So coordinates for coordinate point B would be 9 and -5. Can you guys understand? This is for Roman 1. Find the coordinates of B. Can you understand? Cannot? Boleh? Others? Okay, Ahmad, Darman, Joel, Tasya. Is it okay? Kenan. Okay, thank you for responding, Darman. Continuing with Roman B. Question is find the coordinates of M. Okay, so now you can label here small little. B you already know, it's B you already know, which is 9 and 5, -5, right? The coordinate. Using that, you can find Roman 2, which is coordinate of M. Midpoint of AB, x1 plus x2 divided by 2, y1 plus y2 divided by 2. Anyone know what comes first? Midpoint formula, right? Midpoint formula. Need to know this. -7 plus 9. 97 is 9, plus 9 divided by 2 plus 3 plus -5. So which is x1, x2, y1, y2, you all know, right? You all definitely know. Okay, and then divided by 2 is part of the formula. You'll be getting 1 and -1. Coordinates of point M will be 1 and -1. See, the Roman 2 question is very, very short and good. You know mid-mark formula, you can do. Don't know, lose 1 mark or 2 mark. So the most important part when you can do Roman 1 B1, you can definitely do Roman 2. Okay, don't underestimate midpoint formula. I know modern maths is easy, but it helps. Okay. Children will be continuing with example 3.
Okay, so example 3, question is find the ratio AP, ratio PB such that point P, -1, 2 divides a line segment joining point A, -2, 1 and point B, 2, 5. So the question has given the coordinates and they're asking us to find the ratio. Okay, so at first we will let's just, if possible, like try to like just roughly draw the x-axis, y-axis and the line, and just plot the points yourself so it's easier for you to understand. Okay, so here they have drawn, and then you can just plot the point A and then P. Then the question has said P divides the line, so P is the middle dot, and then D. So by this you know that mn is the ratio. You can just write mn, and then you all know the formula, which is so you all can just sub the coordinate value into the formula, then uh, you all can equate it to -1 since the coordinate of p is -1. Okay, so it will be n -2 plus m2 over m plus n equals -1. Okay, and then move the m plus n to the other side and then expand. You'll get 2m minus 2n equals to -m minus n. Okay, make sure to expand properly because there's negative here, so must change the symbol. Okay, then move around, and then we get 3m equals to n, and then move the 3 to the other side and n to the left hand side, so it'll be m over n equals to 1 over 3. So m over n equals 1 over 3 means you can also write in ratio form, which will be m ratio n equals to 1 ratio 3, which is AP ratio PB equals to 1 ratio 3. Okay, so that's how you do this question. Okay, understand everyone? If you don't understand, we can move to self-practice 7.2. You can do one question maybe. We can do question 2 maybe. Is it okay, or y'all want to do any other question? Maybe y'all can try
Okay,
question 2.
let's do question number 1, question ABC. Is it okay? Or you want to do question 2?
I think I can do question 1 also.
Okay, ABC 3 question also. I want you all to try first.
Everyone
No
try,
point
we'll give you some time.
both of us discussing. You all also must try. Okay? I'll be showing my screen, the working, if you all can. Okay? Please try. Thank you. Let's try these three questions. Okay, I want Ahmad to do question 1 and Darman to do question 2. And when you're working, or maybe just type out your answer, please do chat as well. Thank you. Two to 3 minutes, please.
Pritika, can you present your screen so they can see the questions? Okay, thank you. One more minute.
Ahmad Garment. Okay. Kalau dah siap, boleh type atau mic. Ahmad, boleh. I think discuss the question because we are running out of time. But I would appreciate you guys responding too, because there's no point if just both of our tutors talk and there's no question form. Okay. So point P divides the line segment joining point A and B below in the given ratios. Find the coordinates of P. So question 8, we give ratio A 3:7, ratio B 97:2, ratio C. Sorry, only two ratios. Sorry, got it. And the ratio is ratio 3 2. What I will do first step is write down the formula. No matter you know it is given, just write down. Second step, I will draw my own diagram, although it's not given. I will draw. So, okay, series 7, 3, E, 7, 2. 8 is 3. So 3. Then 2 times 3, series 2, times 3. 3 times 7, negative times 3 plus 2, both of it, the ratio. Same thing for y. It's showing in two different colors, so it'll be okay. 2 times circle. Two times 2. So it's okay. Continuing with okay. Same thing only. There's nothing to do. So you got the x and let's continue y. Continues with b and it's 2, 1. Okay. C. Continue with b. That's it. Very simple. Okay. We have solved all 3 questions. Muhammad, Harap Paham. This one I showed in 2 different colors. Other 2 questions just ignore. Yeah. Okay. And that's it for today lah. Right. Thank you. Thank you for responding, Ahmad.
Okay, so that's all for today's class.
Yeah.
We'll
Thank
continue with
you.
chapter 7 next week. Okay.
Alright.
Thank you.
Thank you for joining.
Thank you.
Bye bye.